My name is Andrew Osipov. I'm the Distinguished Engineer and Portfolio CTO for Cisco Cloud and Network Security. And today we're here to talk about a couple of things we announced at Cisco Live. And I know it was tons of content at Cisco Live, but I wanted some of that to settle down a little bit and come in and talk in some more details about certain aspects of those announcements, including the new Cisco Secure Firewall 4200 series appliances. At Cisco Live Amsterdam, I talked about the Cisco Secure Firewall 3100. So now we're on to the 4200 new family of appliances, and also the corresponding Cisco Secure Firewall 7.4 software and some really cool capability that it enables along with those hardware appliances. But before we go too deep into the hardware and the software and the features, I want to set the stage. And again, if you watched me in Amsterdam, it may be a bit of a repetition for you, but still, it's important for me to set the stage as to why we are doing some of those things we're doing with the hardware and the software. What exactly is happening with firewall in general, in our opinion, and there it is. So when you look at the firewall, especially next generation firewalls, traditionally, it's a deep packet inspection appliance that looks at packet by packet by packet for each connection, every single bit and byte coming through its interfaces, and it looks for certain patterns to then make policy decisions, block the bad stuff, allow the good stuff. A couple of trends out there in the industry which have been making firewalls' life somewhat difficult, and those trends are insertion. How do I actually insert this magical appliance in between what I'm trying to protect and what I'm trying to protect from? And then there is the pervasive encryption of everything. If every single packet, every single connection is encrypted, how do I actually gain visibility? How do I actually decrypt and inspect those packets coming through so I can make proper policy decisions? So when it comes to those two trends, there are two distinct use cases, I would say, for inserting the firewall. The first one is the inbound insertion. So insertion aside, yes, assume you found a way to put the firewall in between the outside world and your applications. What do you do about decrypting traffic? How do you get insight into what's coming on the wire into your application? So this is where decryption is still very much possible. So TLS 1.2, now we're on to TLS 1.3. We have QUIC upon us, something that's going to be called HTTP version 3, which combines HTTP with encryption. For all those different connections, as long as you possess the keys to the application, basically your public key infrastructure, you can break into TLS. And that makes full deep packet inspection of all traffic still very much possible. You can apply IPS, web application firewalling, API security, whatever you want as traffic comes in from the untrusted network into your applications. Now, one could say, well, that's great for coming from the internet to the application. What about application to application traffic? Well, things get a little bit more interesting. And let's talk about the other use case, the outbound use case. Your users going to places. Could be a place on the internet, could be a place in your data center, whether on-premises or a public cloud. By the way, I don't like to use the term on-premises because it's not really as much on-premises, because it could be not your premises, could be a colo facility. I like to say privately deployed infrastructure, because you could be in a colo facility, but it is your x86 hardware, it is your appliances, it's something you brought in, but it's not your premises. But anyway, so what happens when your users try to get to potentially untrusted applications? So some of them may be going through the proverbial cloud. So they may not even be crossing your privately deployed firewall. And so what do you do then? And then you go to places like Office 365 and Google Workspaces, where traffic's not only complex to inspect, but also undecryptable. And it's undecryptable because, I said before, if you possess the keys to the exchange, the private keys to the app, you're good. In this case, you don't. The app is owned by somebody else, and they are sure to keep those private keys secure. And so when the TLS session is established, they typically ensure that the client's also secure. So they use some form of out-of-band exchange of the server certificate to the client, so now you cannot break into this conversation. So when you go and you launch your Outlook and you log into your cloud email, that traffic is undecryptable no matter how big of a firewall you put in place or how hard you try. So what do you do? One of the cool things in our umbrella cloud security solution, and I'm going to refer to that later on when I talk about firewall integration with cloud security. One of the cool capabilities of Umbrella is what we call Cloud Access Security Broker, or CASB. And CASB is this special tool which, instead of looking at transit traffic, it actually hooks onto the backend APIs of those cloud productivity applications, and it tries to understand what the user is doing through that. So instead of let's unpack this network connection and figure out if Andrew is going to chat or going to upload a file into Cloud Drive, I'm just going to ask the respective application, and it will tell me exactly what Andrew is trying to do. And Umbrella Cloud Delivery Firewall actually uses that backend CASB capability to enrich its network firewall's ability to identify flows and map them to applications and user activity, which is kind of cool. We are working to move some of that functionality into our privately managed firewall as well. The first step was to pull in the application ID database out of Umbrella, out of CloudLock, out of our cloud security portfolio. When we talk about what we call the intelligent WAN or smart branch, intelligent branch, we actually use some of those app IDs to perform routing decisions better, but more on that later. For clients that are either managed or on your premises, you can do a few things as well. Yes, they are going through the edge firewall, but again, traffic may not be necessarily decryptable, and it's generally expensive to decrypt that traffic at such volume. So we should be able to infer activities based on some of the patterns in this communication. So client going to something outside, we can look at where that outside is, and based on certain patterns in that flow, we can actually make pretty conclusive outcomes of what exact applications, processes they're using. Maybe it's even malware, we can detect that as well. If it's a managed endpoint, we have something called Secure Client, which contains a module called Network Visibility, which actually generates for each packet or each connection established outside, it generates a metadata packet with exactly what this application was, what username was, about 30 or so attributes, and we could down the line consume that on the firewall for near real-time policy enforcement. So the client itself is an untapped wealth of this metadata, this knowledge, which requires very little on the firewall's part to do. Definitely not decrypt anything, but just consume that metadata as it comes in. And on the application side, and that's where things get really interesting, we'll talk about how secure workload, which is really an application security solution, how that fits into the firewall story, and how that complements the firewall's visibility into what is happening, but on the application side. And at the beginning, I said, look, if it's inbound to the application, you can decrypt, you can do all those things. If it is lateral application to application, how do you firewall those connections? Well, this is where secure workload comes in. Again, we'll talk about that a little bit down the line in this session. So with that in mind, let's go into the new Secure Firewall 4200 series appliances. Again, something that builds on the architecture of the 3100 series appliances that we announced last year, and something I talked to you about at great depth in Amsterdam. So 4200 is effectively a refresh of our higher-end 4100 appliances. One thing I'm really, really proud of in the world where every vendor competes for building a bigger box, 5RU, 6RU, 8RU, I think there's some boxes out there like 18 plus rack units. We continue to pack everything into one rack unit. And this is something that my customers told me very clearly, that 1RU is the optimal form factor because they put it as a top-of-rack firewall. Anything up to 3RU is acceptable. Anything beyond that, they just don't respond very well to it. So again, 1RU packing all this new power. It is a completely integrated appliance. So if you had experience managing our 4100 series appliances, you'd remember there is this beast called Firepower Extensible Operating System, FXOS, which manages the chassis, sort of the supervisor chassis manager model. And then there is the application itself sitting on top. It's ASA, Secure Firewall ASA, or Secure Firewall Threat Defense, which is the next generation firewall application. So those two images, two applications were effectively managed separately. We learned again from customer feedback that you prefer an integrated experience. So on the 4200 series, just like the 3100 series, those are integrated. You download one image, you deploy it as either ASA or firewall threat defense. There is no, there's two things you have to manage. Everything is managed from the firewall management center for firewall threat defense, from clustering to multi-instance in a few months or so. And again, looks and feels like one box. You can stack up to 16 of those into one big logical firewall. So even though it's one RU, if you want to build a multi-RU physical firewall, you're welcome to stack multiple of those boxes or stretch them across multiple racks, and this way still achieve that 2+ terabit of firewalling capacity for larger data center and larger edge deployments. Some other boring stuff like NVMe drives, yes, you expect those. That can be RAID together, so you have some kind of redundancy built in. And then the network interfaces, we are stepping up, because if you remember, we went basically 10 gig for the built-in interfaces for the SFP cages. And now we go up to 25 gig, and in the near future we'll also enable 50 gig, which is something cool actually. So traditionally you say, well, you build an appliance, right? So if it's 25 gig, it's 25 gig link. Like, how can you in the future make it into a 50 gig interface without basically shipping a brand new appliance? So there's actually a way to program the modulating frequency on those interfaces, and you can effectively double it when the time comes to allow for higher density, when obviously the transceivers support that as well. So this is more of a software upgrade. So the hardware is already in place. All you do is you up the firmware, enable the different frequency, and now you can double the capacity of those interfaces, double the effective rate, which is to me kind of cool. And then we support a whole plethora of various expansion modules, net modules we call it, network modules, whichever you want to call them. Two groups. There is the standard modules all the way up to 200 and 400 gigabit ports. And there is also something we built for intrusion prevention use cases. They're called fail to wire. So if the power disappears, if the software goes offline, there is a physical relay in those modules for optical interfaces, a little tiny meter which flips in position if the power is removed and effectively reflects the signal out of one port and into the other. So the box becomes essentially a hardware loop even when the power is disconnected. So if you have a particular business critical application where connectivity is more important than security, and I kind of shiver when I even say that, right? To me, security is always more important than anything else. But again, if you have this kind of such an application where connectivity is absolutely critical, you can deploy one of those fail to wire modules, and it will, like the name implies, fail to wire and close that circuit. Let's pop the hood now on and see what's on the inside, the internal architecture of the boxes. I really nerd out on those kind of diagrams, right? Like, yeah, it's great. All the boxes look very similar. Some are smaller, some are bigger, but it's really what's inside that matters. So some things here, and that's kind of cool how we've innovated. We perfected the hardware appliance design over almost 2 decades now. And one element that's carried through at least 15 years or so is this internal switch fabric. Back in the day for us, and still the case for some firewall vendors, interfaces aren't created equal. It depends on which port you plug into. It depends how good of performance you're gonna get. And that's very complicated for customers, because then you're like, well, if I plug into this port, I'll get really good throughput. If I plug into this port, I won't get as good of throughput because it's on a secondary bus, it's more separated from the main CPU. That was painful for our customers. So back about 12 or 15 years ago, when we introduced our first 10 gig firewall, proper 10 gig firewall, ASA 5585, we introduced a switch fabric, which effectively normalizes all the physical ports to its own internal load balancing fabric. So it doesn't matter where you plug in, you still get exactly same bandwidth. It's non-blocking in this case for the external I/O if you actually count those ports, you'll see that even for the 200 gig ports, you'll get as many physical interfaces into the fabric. So this port is never starved. So everything essentially goes up to those CPU uplinks, one or dual 100 gig. But then the traffic doesn't go straight to the x86. It goes into this special FPGA, a field programmable gateway array that we built to do certain things very, very fast in the hardware before those packets get to the main CPU. And one great example of what you could do with traffic before it gets to the CPU is encryption and decryption of packets. And just like the 3100, the 4200 uses what we call the inline crypto engine. Traditionally, encryption decryption tasks are done in the hardware pretty much by everybody, but it's done in what we call the look-aside fashion. So the main CPU, x86, wants to encrypt or decrypt the packet. It ships the packet to the crypto accelerator over the PCI Express bus. The crypto accelerator does its magic, ships the packet back to the CPU. The CPU does its deep inspection. Now we have to re-encrypt it, ships it back to the crypto engine. You get the idea. So for each packet, you traverse the PCI Express bus 6 times, from wire to CPU, CPU to crypto engine to CPU, CPU to crypto engine to CPU, back on the wire, 6 times. Neither the CPU nor the crypto engine is the bottleneck, the PCI Express bus is. And that's why if you look at the vendors who do publish the TLS decryption numbers on a data sheet, and if you measure those that don't, you'd see that once you enable TLS decryption, the performance drops by 90, 95, 97% in some cases. It's a pretty big drop. And most of that is driven by the PCI Express bus traversal. So the inline crypto engine we built in actually has a dedicated link between that FPGA in the middle and the crypto hardware accelerator. So we can send the packet across, get it encrypted or decrypted before it even hits the main CPU, never has to traverse the PCI Express bus, and that's what drives the performance with those appliances. That's what's new and cool, besides being a new shiny cover and still being 1RU and all the other stuff. It's that capability to inspect and decrypt traffic before it gets to the main CPU. I hate boring folks with the datasheet numbers. You can look at it yourself, but just to throw some figures out there to support my point, those new appliances can do up to about 150 gigabit of App ID plus IPS clear text traffic when it comes to IPsec VPN. Notice, and that's directly the result of this inline crypto engine design, we can actually do 145 gigabit of IPsec traffic, which is exactly same as what we do for App ID plus IPS on the biggest appliance. The TLS numbers, we're still tuning them. So it's a little too early for me to get all excited, but the early numbers are really, really solid. So it is up to 5 times what we could get with TLS decryption on the biggest 4100 series appliance. And if you pull up the 4100 data sheet, and you can easily multiply the numbers by 5 times and figure out what I'm talking about. But I'm talking 50, there I said, 50 plus gigabit of TLS decrypted traffic throughput with 50% of TLS traffic, which is truly and again, I'm not trying to put on my marketing hat or anything like that. 50 gig in a single RU for TLS decrypt, that's a lot of throughput. So it makes me very, very happy about what we could achieve with those new appliances.
I have a quick question for you.
Yeah, what's up?
Just on the previous slide, it's Bruno Wallman here. I'm assuming these are racetrack speeds, judging by the size of the packets. Have you run, what sort of performance do they get? Does this appliance get with, say, an iMix mix of packets? Because everything at 1024 is unrealistic in a network environment.
No, it's a fair question, Bruno. I wouldn't say it's unrealistic because I actually did this test on my laptop. I actually captured all the packets for like a week, and I took an average of all my traffic coming out, and I just used it as I would normally use. And the average actually came up to around 1,000 bytes per packet. Obviously, with TCP, you have the handshake, which are smaller packets. You have the payload, which are much bigger than 1,000 bytes. But those are achieved with a real-world HTTP traffic profile. It's 256 kilobyte payload So essentially, you're pulling a 256 kilobyte payload per connection. That's what translates into a 1024 byte packet. And the various players in the industry document their numbers similarly or differently. Some mention the average packet size for the session. Some say, well, let's say 64 kilobyte or 256 kilobyte payloads. Realistically, they all boil down to a very, very similar figure. But if you have smaller average packet size in your environment, it is typically linearly scaled. So if you have, say, 500 byte average packets, it'll be about half of what you're seeing here on the on those numbers. So it's quite linearly follows that progression in packet size versus the throughput.
Okay, thanks for clarifying. Yeah, I was just trying to.
Yeah, I got you.
Some of the marketing, I know all firewall vendors kind of do the same thing, so I was just trying
I got you.
to a real world traffic.
It makes sense, right? And again, I'm not going to say like every single installation there is going to get 145 gig of this traffic rate. No, because you enable features, you enable rules, you enable like file policies, that drops. But we try to test with real world HTTP. So our HTTP profile actually has URLs and it kind of looks and feels like what you would typically get on the wire. Like I hate doing 1500 byte UDP profile because you can go very, very fast. And yes, we have that number on the datasheet as well, but it's completely meaningless in a real world environment because like who is passing 1500 byte average UDP packets, right? But yeah, great question.
Follow-up question to that.
Yeah.
On that previous slide there, are those numbers same regardless whether you're running FTD or ASA code?
So these are FTD numbers specifically. ASA numbers would be higher, but then ASA wouldn't have IPS or app ID, so not quite apples to apples. But these are numbers are FTD specifically. Okay. I feel like showing the kind of the worst set, the more conservative set of numbers is always fair. So yeah, ASA goes, and you can look at the datasheet. The datasheets are posted since this is something we already released. ASA numbers are quite a bit higher. I think ASA goes up to 200 gigabit, so essentially the full uplink capacity.
Okay.
So your max sessions per second and max session, are they same type of improvement over the 4100?
So the max session per second, they not 5 times for sure, and I'll tell you why. So we had the opportunity to obviously improve those, but with the world switching from HTTP 1 to HTTP 2 and quick, there is a lot more multiplexing happening. So back in the day, like you go to your favorite social media site, you open one page, it opens up like 100 HTTP connections to pull 100 individual images. With HTTP 2 and especially quick, you basically have one connection. So it is to the tune of maybe 600,000 to 700,000 connections per second, and a total
more than double.
It's something. It's double to less than double because again, everything. Look, we do a lot of inspection, and like even if each connection record on FTD has not even tripled, quadrupled, I think, since the time we introduced it, because we track more and more parameters. So essentially, it's a trade-off between how much memory you squeeze in there, and those go up to 1 terabyte of RAM versus how much value you get out of it.
And the max sessions probably the 30, 50?
30 to 60 million, in that range. And again, I should probably remember it off the top of my head, but
I
don't.
Comparing to the 4150.
Yep.
Right?
Yeah, exactly. Yeah.
It's on the data sheet.
It is, and that's why I don't bother remembering it. I'm not gonna say it's just because my memory is not as good anymore. It's just because it's somewhere in a data sheet, and I can always look it up. And anyway, so the hardware appliances, that's cool, but it's really the power of the software which enables it all and some more. So let's talk about the Secure Firewall 7.4 software. And before we do that, let me say a few words about our new suggested release, 7.2.4. This is something that we published about a month ago or so, and then it recently became, a couple of weeks ago, it became the suggested release based on the criteria we used, incoming tag case data, new bugs, etc. So we do this sometimes, once in a while. I think it's important to do. Sometimes you just have to stop and pause on the feature development and say, look, we added 300 features or so in each of the last 5 releases. Let's take a pause and create the baseline, the good foundation on which to build new features, new releases. So 7.2.4 is that foundation. It's something we are using as the baseline for 7.4, which is the new release we've announced here, as well as backporting some of those improvements and fixes and enhancements and optimizations into the 7.0 software as well. Am I going to claim this is completely bug-free? No, it would be foolish of me, and it will take away whatever remaining credibility I have in front of you. But it is a very solid effort to test, not just with our internal cases, but also using real customer configurations, real customer profiles, really put it through the cycles and make sure that it doesn't just work in the lab, it actually works in real production customer environments and works very well. So far, the feedback has been tremendous from our customers. Again, I'm not going to stand here and claim there aren't going to be any new defects coming in. They are, and they will be. But this creates this baseline for us to continue building on without a fear of introducing too many features to potentially compromise the stability, which is not something we ever want to do. Some of the other capabilities we introduced, and it's not 7.4. 7.4 sort of the culmination of quite a bit of those. We call them collectively a wide area network features, WAN, branch. But I would make an argument for those features being just as relevant for any kind of enterprise redundant network multi-link design. And this is the way to not just monitor interfaces, monitor links, aggregate links, but also be more intelligent about which application use which links. And I mentioned earlier, we pulled in a whole bunch of application IDs from Umbrella. This is where we use it for application detection on the first packet. Because with policy-based routing, and I look at some of the vendors' documentation out there, they say, well, yeah, you can use our app ID for policy routing. And there's a little footnote. Do not use it if you use NAT or PAT. And, well, a lot of folks use NAT and PAT on the outside interfaces. So why is that the case? Well, because if you use the traditional pattern-based app ID, you cannot do it on the first packet. You have to wait for a few packets into the connection to detect an app, and then it's too late to switch the interface. You're already passing packets. So we pulled in that database and continuously update the cloud application app ID database from Umbrella to be able to detect those apps on the first packet. So we use the power of our cloud security stack to improve the privately deployed firewall's ability to detect those applications. And you can do cool stuff. Then you can say, my collaboration traffic, my WebEx traffic will go across those two interfaces, load balance across them. And if those two fail, both fail, will flip to the third interface. And then you can also do link quality monitoring. Hey, what's the latency? What's the jitter? What's the packet loss across this interface? And applications, again, like collaboration, something that critically depends on no packet loss, little jitter. You can direct over certain links versus the other. Even include something, and that was, again, I geek out on that as well. Back in the day, some years ago, I was really into voice over IP, and we use something called MOS scores, mean opinion scores. Basically, you pick up the phone, you call somebody, and you rate, you give that conversation a grade with respect to how well you could hear the other party. So now we live in a world where we can do this algorithmically. So the firewall can actually compute the MOS score to a particular destination and route your traffic based on that, which again, I find kind of cool.
You're folding more of the SD-WAN stuff into the firewall.
Yeah.
I mean, direct internet. I mean, the previous feature and this one are
Sure.
basic features and
yeah,
basically all SD-WAN.
So yes, that's correct. Again, I think like
I was going to say the same thing. Yeah.
I was actually wondering if this is Viptela code.
No, it's not. It's our code. But again, it's not really like SD-WAN to me. There's three things. There's data plane, there is control plane, management plane. So data plane, it's applicable across the board, right? Like WAN is not the only place you want to aggregate links. I have large enterprise customers who want to say, hey, I want traffic to fan across those 8 links using BGP, right? One dies, too bad, right? It's layer 3 redundancy. But yes, there is also branch and WAN. So yes, the data plane is absolutely something that you would see in SD-WAN. Then it gets a little more complicated. The control plane for SD-WAN could be proprietary, could be something like IKE, ISACAM for IPsec. Great, we support standard-based IPsec, ISACAM, IKE. We don't do anything proprietary. And management plane is ours, what you configure in Firewall Management Center. Viptela and Meraki, they bring unique advantages in terms of that management plane and a little bit of a control plane to make it a turnkey SD-WAN, what I call, versus if you just want to get a bunch of firewalls and build your own WAN using SD concepts, which is really what we're going after. But we are definitely working with our enterprise networking side to see what is the better combination of perhaps Viptela or Meraki SD-WAN control plane, right? Using those data plane capabilities.
Correct. Because at enterprise, I'm looking at the options available, right? How do I unify this? I got Meraki, I got Viptela stuff. I have this. Then at some point, I'm going to see probably 1,000 ICE integration slides show up somewhere, right? So,
Sure, fair.
so then, what's your recommendation, though? I mean, like if customers came to you and asked you, like, how do I think about it, given the new capabilities, the firewall, and these cool features that make them more SD-WAN? Like what do you say to your customer?
So I'll repeat what I think I already said, right? If you want a turnkey SD-WAN, like you don't want to turn the knobs, you don't want to configure BGP, you don't want to configure IPsec, ISACAM, either Meraki or Viptela is the right solution for you. It's tremendously more powerful too for like proper SD-WAN. Also depending on which team is deploying. Is the security team deploying something that has SD property? I think they will be more comfortable with the firewalls, firewall building blocks. If it's the networking team deploying SD-WAN with a little bit of security, I think they'd be very, very happy with Viptela. But like I said, there is an ongoing conversation inside, in between our different businesses, because we definitely want to have one unified experience, but at the same time, we want to cater to all kinds of customers, right? Like if I go into my favorite home improvement store and I say, look, I want to build a deck, go and show me what I need to get. They're like, no. Look, here's the all ready to build deck. We'll build it for you. You're like, no. I want to buy the individual pieces, lumber, tools, everything. Like, no, you can't do that. So then I go to a different store which will happily sell me that, right? So I want to support both customers who want a turnkey, the pre-built deck, versus somebody who wants to pick the lumber, the tools, the bolts and nails and the hardware and do it all themselves. So that's really where the line is drawn. Another question I get.
This is Steve. I want to ask a little more geeky question on the previous feature. So when you're doing this as a network engineer and you want to control the path, are you able to distinguish the download via the upload versus the upload to detect when it's coming in on the one ISP, coming back on the other, and therefore which one is giving you the problem? Are you able to detect to that level?
So this doesn't, so I don't know, 1,000 eyes was mentioned. It doesn't actually do that. So the link monitoring is limited to either ICMP or HTTP ping. So it doesn't actually look at, like, if you're downloading a video through multiple paths, which path is giving you trouble. So it doesn't extend there, which is why I said that if you look at Viptela and other SD-WAN specific solutions, they do a lot more than that. This is just basic link monitoring to a destination to see if like your WebEx traffic is going to be impacted or not. All right, so a few words on cloud security. So I mentioned earlier, Umbrella has those really cool bits like CASB, Cloud Access Security Broker, integrates with well-known SaaS applications. Question comes up a lot. Why would I deploy cloud delivery security when I already have an edge firewall? Should I have an edge firewall if I do things in the cloud? The ultimate truth is the cloud's your stuff running on somebody else's hardware. So if you take your edge firewall, put it in the cloud, yes, you are offloading the scale problem to somebody else. You're also paying for it. But the functional problem of decrypting traffic and everything else remains the same as it does with the privately deployed firewall, on-premises firewall. The two categories of traffic which I think cloud does a lot better on than any kind of on-premises device, and one is, well, DNS, right? We have Umbrella Security Intelligence, which deploys the power of machine learning to do a lot of things, a lot of checks, a lot of contextual, lexicographical checks around new domains, flux domains, and can immediately tell you if this domain is risky or not. So this is not something you'd be able to do effectively on your on-premises device. So we support one-click redirection of all your DNS traffic to Umbrella. The other one, I already mentioned, it's the SaaS traffic through CASB. Again, CASB can do a much better job telling you what the user is doing, rather than trying to decrypt that traffic on your edge firewall. So for those two categories of traffic, I'd say it makes complete sense to redirect to Umbrella, even if you have an edge next generation firewall. And we support this one-click API integration between Firewall Management Center and Umbrella dashboard. So all the policies, everything shows up on FMC, and you can just one-click tie them together. So to me, it's something it's an underrated but a very, very powerful integration out there. Everybody talks about zero trust network access. What really hurts me as a security practitioner is that some folks say, well, once you authenticate and authorize somebody to access the application, you're good. the zero trust's in place, it's established, let them do whatever they want to do. Well, if you read the news, there have been some breaches lately where, yeah, somebody picked up valid credentials, logged in as the legitimate user, got authorized, got postured, and then went off and pulled a whole bunch of data across the enterprise without much of an oversight. So my thinking, this is kind of one of my personal pet projects, right? Well, the firewall FTD already does a lot of this deep packet inspection, does decryption, all those things. Why not add just a little layer of authentication and posture checks and essentially provide a proper zero trust experience for not just authenticating and authorizing, but also inspecting this traffic inline. This is what we delivered in Secure Firewall 7.4 software. Essentially, a user connects to a private application through fully qualified domain name. FTD intercepts that connection, authorizes, authenticates against your identity provider of choice. We'd love it to be Cisco Duo. It's not Cisco Duo. Fine. It will work with whatever IDP, whatever MFA you choose, and then FTD will pass the connection, the authorized, authenticated connection onto the private application, acting as a reverse proxy, but also continuously checking that traffic for IPS and file policy checks because it's already decrypting at a TLS layer. And not just for outside interfaces, the same approach we support for campus to data center, campus to campus, whichever internal connections you can expect. So if you want your campus users to go through the same reverse proxy, zero trust application access, we call it, checks, so be it. We don't really care if it's from the internet or from your campus network. And the way it looks, so when you define the application, you can, and you should, define a different application FQDN for the private side versus public side. So you say, look, this is the qualified domain name that's the external clients know the application by, and this is my internal FQDN that FTD actually makes the connection to. There is some SAML magic. Like I said, any SAML capable IDP is supported, and then the coup de grace is the IPS and file policies you want to associate with this particular kind of traffic. And in the end, you can have multiple applications, you can have groups of applications. So this is your full zero trust application access policy where FTD acts as a gateway and authenticates, authorizes, but also inspects, continuously inspects all traffic coming to the application for threats.
Do you have a sizing guide for that? It feels heavy, like a heavy lift for that box to do all that.
So it's not really compared to, again, just what you usually do on the IPS and firewall for inspection. TLS decryption is obviously the big piece, but performance-wise, yes, we will have the sizing guide published as well, but it is actually quite comparable to just decrypting any traffic for IPS and file policies as it is. So those TLS decryption figures we have on the datasheet for those platforms, they will still hold true.
Even more state maintenance, though.
Not a whole lot, because again, connection is a connection, right? Yes, you're terminating one TLS and you're opening the other, but ultimately that's how TLS decryption works anyway. So we actually seen really, really good performance with this, and that was the motivation for it. If you're going to decrypt and IPS inline inspect, might as well do just one extra thing at the beginning of the session, authenticate and authorize it. Once it's authenticated, authorized, there is almost zero overhead on top of regular inspection.
It's like a weird place to put this, isn't it? Like.
Why not?
It feels a little unnatural to me, right? Because in order for this to work, your target application has to whitelist the source IP of the external interface of the firewall. Otherwise, your controls are only in place for the people going through that firewall. No?
No, we do. We use a token, HTTP token inside. So this is SAML, right? So it's not by IP address. So essentially, once you authenticate, essentially you authenticate against the application and the firewall ZTAA proxy at the same time. So there is no, it's not an IP based.
So the application, the target application will take a SAML assertion from the firewall as part of the process?
Correct.
So now you become the SSO IDP, the firewall essentially becomes that.
Oh, yeah. Yeah. Well, it's it's not the IDP, it's the IDP, right?
It's your ID broker.
The guide.
You're now an ID broker for the IDP, doing a SAML assertion to the application that then lets you through, essentially.
Essentially, yes. Well, basically, essentially the IDP authorizes access to both the firewall and to the application. So it shares so think of it, you authenticate and authorize to the application, you get the token, and you use that token to knock on the door of the firewall and get through. I would
so the tokens
support it this way.
So after the authentication, the token is there. Well, I see. So then the application has a token, then it's passed through.
Yep.
That goes all the way
Yep.
through to the actual application
Exactly.
itself.
Exactly. Yeah, and since most customers have a form of a firewall at the edge of their on-premises data center, it is a relatively natural position, especially for those federal customers, state customers who don't quite go for the SSC type
So the configuration for the outside, the application itself, say I'm Salesforce, right? The IDP SSO configuration, the IDP is pointing to the firewall, Azure AD, or whatever it is. How does that get configured? I'm a little confused.
So Salesforce probably wouldn't be the perfect example because Salesforce is a cloud application. This is more for your private applications hosted on your premise.
I had a private version.
Yeah. Yeah. So essentially,
full version of Sugar CRM that I'm running internally.
Yeah.
Then I configure the authentication so that the SSO is the Azure AD.
Something, anything your ADP supports, right? So, and you'll see in the configuration, and we can chat a little bit deeper.
Okay, yeah,
a little bit deeper later, yeah. But essentially, your SAML provider is actually application specific. So we actually go to whichever link is published for the application when you do the SAML enrollment for ADP, and we just pull from that.
But then the external application is still reachable and authenticated.
Totally.
So I don't have to go through the firewall.
If you are inside, you don't. But then, if
I don't get all the policies.
Well, you still do because that policy may be independent. If you're coming from campus to the data center, you still subject to the same IPS file policies, right? You have it configured.
Sure,
but you can block. So you can block direct access to the application and only expose it through the FQDM. Anyway, let's spend a few minutes after this.
It feels really weird compared to all the other products in the space that are put in different places.
Okay.
That's
okay. Yeah, let's definitely have a chat about that. But let's move on a little bit and talk about Encrypted Visibility Engine. And I think I spent some time in Amsterdam. I'll just do a quick recap. It's our way of differentiating client-side processes by examining only a few outer headers. So we look at something like TLS client hello, and there is enough pattern variation in there to say one is Firefox, one is Tor without having to decrypt anything. We shipped it about a year and a half ago before machine learning and artificial intelligence was on in the title of every article out there. And essentially what you got on the firewall, you had those process name and a confidence score saying, look, we are 90% confident this is wget versus a Python script versus something else. And we also score for possibility of that connection being generated by known malware. And with 7.4 specifically, we introduced this new knob where you can block connections which score high enough on this malware likelihood scale. And down the line, we continue to invest into that. We want to also do conditional decryption. That gives you an idea, but essentially the line of thinking here is instead of decrypting everything, let's use machine learning, power artificial intelligence to zero in on potentially malicious connections and then apply additional security to them and them alone versus everything else that may be benign. Rule analysis.
This is Steve. A quick question on that feature. This seems interesting. Do you have a lot of clients using this, and do you have feedback on what the false positive rate on something like this is?
We do quite a few, and actually one of them was very methodical recently and did an actual analysis of how effective and efficient that is compared to traditional pattern-based. First of all, in our in-house testing, a lot of EVE was more effective against evasive applications than traditional pattern-based methods because pattern-based, pattern can be changed. Your overall behavior is much more difficult to change. And so this customer confirmed as well that this is actually highly effective and efficient in detecting those applications. So far the feedback is really, really good, especially considering that it comes with no performance impact. And a lot of our customers respect the privacy and do not want to decrypt that kind of traffic. So it is actually very.
What about the false positive aspects of it? I understand it's probably pretty effective at stopping stuff, but do you have feedback on the amount of times they get complaint tickets that it's blocking something legitimate?
Haven't seen any yet. Haven't seen any. Not to say they don't happen. We haven't received any feedback for misdetecting something as a threat where it wasn't. Again, not to say that it doesn't happen, but I haven't seen any cases come in like that.
Yeah, because these are the type of features I always had trouble convincing management to turn on because of the fear of false positives, or in some basis the experience of
It's fair, but I've also gotten false positives for pattern-based app IDs, right? And we don't have enough time here, but I have stories to tell about one customer who was trying to block an anonymizer. We kept updating the signature for the vendor to overnight update that pattern, and that was a very, very interesting game of cat and mouse.
Yeah. People don't like not being able to get quote unquote legitimate.
Yeah. Anyway, let's again, we're a little bit getting a little bit thin on time, and I'm tremendously enjoying this conversation and session. But we also have some other cool stuff we want to show you in the next session. So let me just quickly talk about a few management side enhancements. One is the better rule analysis, so something that we all experience to configure a big firewall policy. I have overlapping rules, duplicate rules. It's really hard to catch those by hand, so we've introduced this tool to both detect overlaps as well as what we call shadow rules. Is this low priority rule covering something that was blocked previously, and there's no point in that? So all that intelligence is coming to Firewall Management Center as well. User identity with Azure AD, it's a really cool way of kind of shifting your IDP into the cloud. Now, Azure AD is not the same as your traditional Active Directory, a very, very, very different model. There's like all those passionate arguments whether it's an IDP or is it a directory, and it's really not a directory, it's more of an IDP. But the gist is we integrate with it for passive user ID now. The cool things are that you no longer require an explicit policy for identity, because those streaming IDs just come in from ICE through PX Grid. And also the user and group membership is updated in real time because of the API integration versus us having to download the entire directory from LDAP every 24 hours or so. So nice improvement to our AD store. And in general, we actually supported a lot of policy or attribute-based policies, from the traditional scalable group tags to dynamic objects in SecureX to what we call now the dynamic attribute connector, which pulls mappings attribute to IP address mapping from the likes of vCenter, vSphere, NSX, AWS, various Azure, GCP, various public cloud providers, Office 365 as well. So you can pretty much configure any policies using attributes versus static IP addresses. And I think that's exactly what makes the firewall easier to use rather than remember everything or keep everything in your head. This also powers the integration between Secure Workload and our firewall policies. So Secure Workload, which is an application security solution, can control firewall policy, can deploy firewall policies. You can configure it to deploy policies to certain domains. It can combine rules that you already have on your firewall and add its own. I think one of the coolest things that it enables, you can create an object called vulnerable applications. And Firewall doesn't know what vulnerable applications are, but Workload knows, because it knows what versions are running on each and every application in your data center. And it can program that into the policy, saying, look, every application which has CVE or CVE vulnerability disclosures with CVS score of X or above, it will be populated into this particular object, and Firewall can deny access. And it also powers something called application virtual patching, which is a new capability in Workload 3.8, which not only populates the object, it actually populates network discovery policy on FMC with specific CVE and CVSS information for each individual workload. So instead of now guessing what I'm running on this particular host, is this SQL application or that SQL application, what package version it is, Workload can tell FMC exactly what that is. So when you run firepower recommendations, the fidelity of your signature set is much more precise, much more targeted. So now we say, look, this is a specific Microsoft SQL package for this version, and it's affected by those vulnerabilities, so we can program just this one signature and this signature alone. And last but not the least, and this is more of an intro to another session we're going to do, is Multicloud Defense, which is a solution for public cloud to combine multiple security products into one stack. Again, tremendously powerful and useful for those customers who don't want to pull 5 different virtual machine firewalls from 5 different vendors and configure it all at once. But that's something we're going to find out in the next session. I thank you very much for sticking with me. It was a pleasure being here. I'll see you next time.